Hi everyone, I'm Weiss. I'm an AI and machine learning consultant, and I'm here to talk to you about the unspoken problems with machine learning in security. So on the agenda, we'll have three parts. First, since I'm claiming that there are unspoken problems in machine learning in security, let's talk about that. Let's talk about, are we actually lagging behind the security industry compared with other domains? Then we'll talk about why that is the case. And last but not least, we'll talk about what we can do to improve the state of machine learning in the cybersecurity industry. Let's start with the first section. Are we lagging behind? So basically, machine learning is the most futuristic technology we have today. I don't know how familiar you all are with things that the machine learning industry has achieved, but it's basically a sci-fi movie. So to save words, I'll just show you a few videos of some of the state-of-the-art that we have today. Let's start with self-driving cars, autonomous vehicles. It's pretty straightforward, and I assume most of you know that where we're at today with that is really impressive. We basically have self-driving cars, which drive better than most humans. Let's see a short video of that. So again, this is pretty straightforward. There isn't going to be anything exciting in this video. It's just a car that drives by itself. It lanes, it stops at the red light, it moves at a green light, it goes together with the lane when it curves, and as you can see, the driver isn't doing anything at all. I wasn't able to get accurate statistics, but it seems, again, that the level that they've achieved at the moment is better than most human drivers. Next, let's take a look at a project called Everybody Dance Now. Basically, what it does, you know what, I'll let you see by yourself. So you can see how using a video clip that wasn't even taken especially for this purpose, they were able to make their two targets. The targets were filmed for this purpose, but they were able to make the target supposedly dance the same as the source video, the dancer in the source video. Then we have deepfake videos, where we can create videos of people doing insane things they never actually did or said. Let's take a look at Trump.
My fellow Americans, in this age of information and misinformation, we know deepfake videos have never been easier to produce. For example, it would be easy now to make me say ridiculous things like, I'm injecting sunshine. That's why my face is orange. Or, I think I deserve a Nobel Prize, meaning a gift card to half of Barnes & Noble.
There are many more deepfakes of Trump, Obama, and other people on YouTube. I recommend taking a look at them later. And last but not least, I don't know if you've heard of GPT-3. It's a language model that was released this past year, and has some astounding results. Here's a short video clip that shows how the machines are gonna steal our jobs, and specifically with GPT-3 writing code.
The next example is a coding example. And so this is dbuild.co, and they're describing an application that is a basic to-do list application. And so what the software is doing is it's generating a React application, all of the functions and procedures, all of the things that are necessary to create a React component to handle to-do. And you can see it works. You can add items to the to-do list. There's all the events and triggers for handling the interactions of the application, and it's all generated on the fly by artificial intelligence. Just amazing what we're able to do with AI, both the design and development aspects.
Okay, so that was a quick review of what we have with machine learning in other domains. I hope you're as impressed as I was when I first encountered each of those. Let's talk about machine learning and security. So, machine learning and security today. Let's start with the good stuff, is that there are some significant improvements in malware detection. I don't know if any of you have heard of the next generation antivirus, which utilizes deep learning techniques, which is a type of machine learning to have really impressive results for identifying malware. So that is something that we can point to where machine learning really works in security. And there's also some promise for network intrusion detection. It's not yet prominent in practice, though. But all in all, machine learning models in the security industry have so-so performance. Usually, machine learning only makes for a small part of the core product, and the data and machine learning technology are mostly underutilized. We really don't use them to most of their capacity even in the industry. In general, it's really, if you're somewhat familiar with machine learning, both in security and in other domains, it's rather clear that the security industry is lagging behind in everything it has to do with machine learning. So the question is why? Why is that the case? Why are we lagging behind? So it seems like anomaly detection algorithms are perfect for the security industry, and indeed they're very common. They're used. They might be one of the most used algorithms in machine learning and security, but they are far from perfect. Because here's the thing. First of all, they have a really high false positive rate. And what I mean by that is cases when the model marks an activity as malicious or as fraudulent, depends on what the model is supposed to be doing, when that's not actually the case. And the reason is that legitimate user activity is also often anomalous. While anomaly detection algorithms they can be really effective at spotting malicious activity, they can also be triggered by legitimate activity that is somewhat unexpected. It's different from security than, for instance, when anomaly detection is used in manufacturing. Because in manufacturing, I want to know about any anomalous event. If something anomalous happened, I probably want to know about it. I don't expect things to deviate from the normal. But with user behavior, that's not really the case. Also, we have a higher cost of errors than other domains. We really don't want to miss those attacks. When we have the attacks, we want to make sure that we spot them, and the high false positive rate also can be quite expensive. I mean, what do we do? Do we just block everything that the model tags as malicious, and then we block legit activity, or do we wait for manual review of an analyst, which means that we can't act immediately? It's a real problem. And another problem that we have with anomaly detection is that since it's unsupervised, since we don't have those labels that I mentioned earlier, basically what we use as the so-called ground truth, which is what the model uses to learn, are human designed features. What the data scientists, machine learning engineers that develop the model in the first place, what they define as important. And that means that, first of all, it's very prone to human bias. And also that the model would only spot MOs that we already know. It would only notice deviations in characteristics of the data that the human designing it noticed. Another problem we have with machine learning security is the changing environment. The environment is constantly changing, which is unlike most machine learning domains. For example, earlier we saw computer vision, which is everything that has to do with image processing. And we saw NLP with GPT-3 that writes code. So the way things around us look and the way images look and also language, they don't change as rapidly. I mean, obviously there are some changes, but at a much slower rate. And then on the other hand, we have a constantly changing environment. We have new devices that come in, we have new apps, we have new protocols, we have new everything. And that means that the data, if I'm training a model on data from a specific year, because that's what I have, and then 2 years later it could be completely outdated. Because that everything changed, and then my model is trained on old data, and it's simply not as good. So it's really a problem for a learning model. And something that we might consider as part of the changing environment, but is also unique in its own, is an adapting adversary. As we become better at securing our devices and networks, attackers become better at outsmarting our defenses. And this is a problem that is uncommon in most fields, because if I have, for example, if we take Everybody Dance Now, the project I showed you earlier, then dancers won't try, well, most of them probably won't start trying to dance differently so the algorithm can spot them. Lanes in the road and stoplights are not going to change just so they can trick the algorithm. The language, even though language changes and evolves, it doesn't do so in the specific way that would make language models have a higher error rate. So this is also something that we have to deal with that is very uncommon in other domains and is not usually a problem that machine learning models need to handle. Then we have tagging. And again, what I mean by tagging is getting the labels, for example, if I'm looking at a data set of transactions, then figuring out which of the transactions are legitimate and which are fraudulent. And when we're talking about computer vision and NLP, tag data sets are much easier to get. For example, if I'm building a model that wants to identify pictures of cats, I can pretty much type cat into Google and I'll get a lot of photos, and most of them would be accurately tagged as cat. And for NLP, what I need is basically, of course, it depends on the task, but if I'm training a general language model as GPT-3 that we saw earlier, then what I need is basically just a corpus of natural language. I can download Wikipedia and work with that. I can scrape tweets off Twitter and get that as a tag data set. And we can't really do that in security. The first reason is that we need expertise. A lot of machine learning models get their tag data sets from crowdsourcing, things like Mechanical Turk, for example. I can't do that with security data sets. Even if I would have been able to put it on Mechanical Turk for just random people to tag, I really need a domain expert to be able to say which activity, for example, is malicious. And I also need context. Even the domain expert won't be able to say if the activity of a certain computer is suspicious or not without the context. And that's a problem we don't really have if we're talking about pictures of dogs, for example, which stay pretty much the same pictures of dogs, regardless of the context. Then we also have confidentiality. We will provide services to companies. We monitor their activities, their transactions, their users, whatever task we do. We can't really just go and put these out in the world, that data. And it's also, we have that at incredible scale. For example, when I worked for Amis and we monitored networks of computers and IoT, and you have an unbelievable number of events per second. It's not really something that's easy to tag. So those bigger data sets really mean bigger tagging problems. And you could say, well, if the data set is too big, then why not just sample? Why won't I just take a small part of it and use that? And that way I don't have to use all of the data set. But the thing is that usually the class I'm looking for, the malicious activities, the fraudulent transactions, that would only be a really small part of the data. So it's not really something I can do. And this also brings me to the next reason why we have more trouble with machine learning security, which is imbalanced classes. What I mean by that is when those are cases when different classes in the data are extremely over or underrepresented. You can see an illustration here. For example, we have class 1, which is very common. Then you only have a little bit of class 2. This is actually what's shown in the illustration is actually a much better case than what we usually have in security. We would usually have only a fraction of malicious activity compared with the legitimate activity. And the problem is that machine learning models, the algorithms, the mathematics that sit at the base of the model, those really depend on the different classes being pretty much the same, present in the data pretty much the same. And then when we have extremely imbalanced classes, that results in poor predictive performance, especially for the minority class, which is the one that we're usually more interested in. So that is a major problem when we're aiming to identify fraud or attacks. And while there are some common solutions that exist, I won't go too much into that, but basically we can undersample or oversample. We could manufacture synthetic data. There are some solutions, but they're limited and they are not as good as simply having the proper data in the first place. Another factor that we have in the security industry that is part of why the machine learning is somewhat lagging behind other domains is the need for explainability. So when we're talking about the state-of-the-art machine learning models and what we saw in computer vision and NLP, those are mostly used on deep learning techniques. I mentioned it earlier. Basically, deep learning is machine learning that's based on artificial neural networks. It's a certain type of architecture of machine learning algorithms. They're very computationally expensive. They're very complex, but they have amazing results. But then they're also considered black boxes. They are not explainable. They're not, when you get the output, when you get a certain prediction or certain classification, it's really hard to know why the model made that decision. And in security, decision-making requires explainability. We're not the only domain where we have that. That is definitely not the case, but I think it does provide more of a challenge in security than in other domains. For example, if we're talking healthcare, then a lot of times the doctors or radiologists or any healthcare providers, they might use machine learning to facilitate their process. And we do need explainability for healthcare, but since it's not real time and it's at a much smaller scale, and usually those models would be humans would use them to support their decisions and not just replace their decisions, which is, again, things that are more available or possible because we're talking smaller scale and slower process. Then it's not as important for the model to be able to explain why it made the decision that it made. And I do want to mention that basically deep learning could still be used with added-on explainability models. Those solutions do exist, but they are very imperfect and they're very complex. And it does add another challenge, and it makes deep learning not as attractive for security as it might be for other domains. Then we have the problem of confidentiality, because when we're talking about other domains, then they have public data sets, first of all, which is something that a lot of different people could use to not waste time and effort in getting the right data, but focus just on getting somewhere with their models. Also, those public data sets, they mean that you can have public baselines, benchmarks. So if I did something that I think is amazing and I want to tell the rest of the industry, oh, I used such a method in my model and it gave you really good results and you should check it out, I could run my model on the basic public data sets and then compare it to the benchmark for that data set. And that would really help my peers to assess how good my solution is. Also, there are publicly released trained models. GPT-3 that we saw earlier, for example, it's a model that took unbelievably expensive resources, and I mean the time, both the human times invested in creating this model and just the computational resources for training it. It's not something that every company could do. So the company that did it, they trained a model and then they partially released it. Basically, they gave partial access to its API for other people to use, for other researchers and companies to use. This is something that we have a lot in NLP, for example, BERT, or I don't want to go too much into the details, but those of you who know it know that there are a lot of publicly released trained models that allow even smaller companies or individual researchers to work and basically build off the work of each other. And we don't really have that. I mean, basically all of those examples that I gave, they enable not only direct collaboration, but also a way to compare new methods and algorithms. And when we're talking about security, then the companies are bound by confidentiality. Again, we provide services, so we can't really take our clients' data and just put it out there. And there's also no natively public data available. And what I mean by that is that while a lot of companies that provide services, they're bound by confidentiality. So for example, if I had a company that would take the photographs of construction sites and then give an estimate of the status of the building, how long it's gonna take to until it's complete, just for example. Then I also can just take the data of my clients and put it out there, but I can get I can get non-confidential data, just photos of construction sites that are not something that I got from my clients. And that is something that could be a public data set. That is something that I would be able to share with peers. But then if we're talking about security, so for example, the example I've used many times in this talk, if I'm doing network monitoring, and then you don't really have that data just publicly available out there. It's not like I can say, okay, well, I want to use my client's data, but I'll just go online and get the publicly available data of network activity. So this is another obstacle. This is something else that sets us back. And it's probably worth mentioning that that might be the reason that we're doing better with malware, because malware is something that is publicly available and is not confidential. And as I mentioned earlier in the talk, the the aspect in machine learning security that is most advanced at the moment is malware detection. It's next generation antivirus machine learning. And that could be the reason, or I assume one of the reasons why that's the case. It's worth mentioning that there are a few publicly available datasets in the security domain, but they're either small or outdated or both, and they're not really something that we can use. I want to read a quote of a paper that I read that talks about machine learning in the security domain. Many researchers are struggling to find comprehensive and valid datasets to test and evaluate their proposed techniques, and having a suitable dataset is a significant challenge in itself. In order to test the efficiency of such mechanisms, reliable datasets are needed that, 1, contain both benign and several attacks, 2, meet real-world criteria, and 3, are publicly available. So I feel like this sums up a lot of what I talked about of this being a real problem that needs addressing. Which brings me to the third and last part of the talk. What can we do to change this? What can we do to close that gap and bring machine learning security closer to where it is in other domains? So the first thing I think we could do is public datasets. This is obviously no small feat. It's not something that we can easily do, but I believe that if companies cooperate on this, we would be able to just publish data sets that we would be able to use both for general cooperation and for the community to use and build upon. And also it would help provide us with benchmark, which is the second thing. Benchmarks that we could use to compare different methods and really advance the conversation about machine learning security and its methodology. The third thing I think would be helpful is direct collaboration. Companies that collaborate directly both for creating data sets and tagging and maybe more, maybe shared projects. While there is some collaboration in the industry today, and it's great to see that it does exist, I feel like we're not using the full potential of what we could achieve by that. So again, public data sets, benchmark direct collaborations, and in general, just encourage an active discussion and indirect collaboration as well in the public domain, which I would believe would result in faster, better progress for the security domain as a whole and would benefit all of us. So to wrap this up, we talked about are we lagging behind in the first place? Is machine learning security really doing not as well as machine learning in other fields? I hope that you're on the same page with me on that one. We then talked about why that is the case. What are the different factors and reasons why we're lagging behind? And last but not least, we talked about what we can do, both as individuals and mostly as companies, to change that. And I want to touch another question, an easier one, of what can you, yes, you watching this, what can you do to change this? And my answer is create a conversation, create a discussion about this, talk about it, and whether you agree or disagree, let's discuss it. I mean, I put my Twitter handle and my LinkedIn page here. You're welcome to, again, whether you agree, especially if you disagree, if you have different insights or different point of view, I would really love it if you would comment on this and create a discussion. Spread a word. If you like this talk, if you think that it's useful, share it with your colleagues and other people in the industry that might find it useful as well. And talk about these things. The first thing we can do to help change this is raise awareness. And maybe if we do that and we start talking about steps we could take to make a change, we'll find ourselves with leading state-of-the-art machine learning models by the time we have this conference next year. So thank you, all of you. Again, I'm Noah Weiss. I'm an AI and machine learning consultant. I work both in the cybersecurity domain, which I quite like, but also other domains. And I help both small and bigger companies with their data and to I help them understand how to use it to reach their goals. If I can help you, let me know. I have my email address and my domain here, and I hope you like this talk.